Hello guys, welcome to Tom's SAT. Today we are hitting linear equations, part 2. Rather than focusing on linear equations where we have y equals mx plus b, today we're going to go a little bit deeper into the type of situations where we see linear relationships, but instead of it being equations, it's going to be inequalities. And we're going to talk about how linear equations can be represented in terms of functions. And we're going to dive a little bit deeper into the change that occur between variables when we have any kind of equation or functions or inequalities that have a linear behavior. And then after that, we'll try 2 tough problems, and that'll be the day. So first things first, we're going to talk about the concept of inequalities. Okay, so for any of you that's made it past middle school or elementary school, you understand that an equation is a statement you make where everything on the left is equal to everything on the right side of the equation. Now, an inequality is when something is not equal. Namely, something is greater than, or less than, or greater than or equal to, or less than or equal to. So if I were to have an equation like y is so if I had an equation like y is less than 20 plus x, that means that y doesn't have to equal what 20 plus x would have to be. It means that y just has to be any value that is less than 20 plus x. So whereas before, when we give x a value, then y must also have a value. Like in this case, if I stuck a 3 in for x, I would have to add 2 to get y is equal to 5. When I try that with an inequality, I don't exactly get the same result. So for a situation like this, if I decide to make x 3, you do 20 plus 3 and you get the idea that y is related to 23. But in this case, y just has to be less than 23, which means that y could be 22, y could be 21, y could be negative 1, y could be negative 100. So when it comes to inequalities, when you have a number for one variable, you actually have an endless number of possible values for what the other variable is allowed to be. And that is the nature of inequalities. And just like with linear equations, we want to be able to go from the equation to graph. With inequalities, we also want to make sure we know how to get from inequality to graph, and also graph to inequality. So let's erase some stuff here and let's do a little bit of practice graphing. So let's start with something basic. So let's say I were to have the inequality y is greater than or equal to 2x plus 7. We're going to think about how to graph this line right now. So the concept of graphing a linear line, be it with an equation or inequality, starts with roughly this idea. I know that I'm going to be doing some shading in a little bit, but the way you figure out the line is the same way we always do it. This inequality right over here resembles the slope-intercept form of y equals mx plus b, where the 7 is my b value, so then that's going to give me the 0.07. So I'm going to get 0, 1, 2, 3, 4, 5, 6, 7, and there goes my first point. And then I'm going to try to represent the slope of 2. So I'm going to go up 2 over 1 to get to my next point. And once I have 2 points, I now have the ability to graph a straight line through these 2 points. And there you have it, with the line of y is greater than or equal to 2x plus 7. Now, here's the thing with inequalities, is that if I am trying to graph this inequality, I am trying to graph all the solutions that would make this statement true. And if that is the case, in this situation right now, y is allowed to be a bunch of numbers. And I'll show you what I mean here. So the thing about an inequality is we need to make a true statement out of it. So if I were to choose x is equal to, if I were to choose x is equal to -3, that means that when I put it through that inequality, I'll get y is greater than or equal to -3 times 2 plus 7, which is going to give me a +1. So y has to be greater than or equal to +1. And that means at the x value of x equals -3, I can have my y value equal 1, which is this point right over here, or I can have it equal 2 or 3 or 4. And you'll notice that this goes on endlessly. And you'll notice that, okay, if these 3 points over here make this inequality a true statement, you would assume that this point would also work, this point would also work, and this point would also work. So that when you graph an inequality, you're not actually just graphing a line, but you're actually shading an entire side of that line, because all those points become a solution for that inequality. And that's the concept of how an inequality works. So this right here is a greater than or equal to sign, and that's when you graph a solid line. And not only are all the points on one side of the line solutions for that inequality, but individual points on the line are also solutions for that inequality. For example, if I tried plugging in -3, 1, which is on the line, into this inequality, I would get 1 is greater than or equal to 2 times -3 plus 7, which would leave me with the inequality of 1 is greater than or equal to 1, which is a true statement. So then in this case, the solutions or the points on the line would be solutions for the inequality. And now that we've tried that one really briefly, we're going to try it for just a greater than or less than symbol inequality. So let's do y is less than 4x minus 10. So this time I'm going to start. So once again, when we graph, we follow the same rules as before. Start with my y-intercept of 0, -10. So I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that point is all the way down here. And the slope is 4. So I'm going to go over 1, up 1, 2, 3, 4. And now that I have 2 points, I can graph it. Now, keep in mind, the thing to keep in mind is that with an inequality, where it's just less than or greater than, individual points on the line would not actually be solutions. So even though I have the point, 1, -1, 2, 3, 4, 5, 6, which is definitely going to be on the line, if I were to try it in inequality, I would get -6 is less than 4 times 1 minus 10, which simplifies into -6 is less than -6, which is not a true statement. So even though I'm going to graph this line, individual points on the line are not actually a solution. So when we graph it, we use a dotted line to represent our answers. Or we use a dotted line to represent the individual points of the line. And now from here, we have to decide which side of the graph we want to shade on, because all the points on one side of the line are going to be my solutions for this inequality. And that gets to be a rather tough decision to make when you have an inequality, because I know in high school there's this trick to think about it where if you say y is less than, then you're saying the y value is below the line of graph. So then looking at a line like this, I would think that I want to shade below it, which tells me that I want to shade on this side. And while that's definitely a good way to do it, the way I like to do it is I like to just pick a easy point. I like to pick a point in a region and see if I make a true or false statement with the inequality. If it makes a true statement, that means all the points on that side are true, are solutions for the inequality. So then all those points I would shade. And if I get a false statement, that means that point is not a solution. So then none of the points on that side of the inequality would be a solution. So for example, just to be really lazy, I'm going to pick the points 0, 0. And if I put it through this inequality, I would get 0 is less than 0 minus 10. So then that's saying 0 is less than -10, which is obviously, once again, not a true statement. That's a false statement. So if this point isn't a solution, that means none of the points on this side of the line are solutions. So then for the solution of this inequality of y is less than 4x minus 10, I would shade it all on the right side over here. And that's how you graph individual inequalities. And that we're good with that, we are going to do something that we're going to talk about another way of graphing straight lines. So sometimes you'll have a linear line, but it won't be in the form of y equals mx plus b. It won't be in slope-intercept form. There are going to be situations where you get x is just less than some number, and there are going to be situations where you get that y is greater than just some number. And you're going to have to be able to understand how to turn that situation into an inequality that you can graph and then represent. I know we didn't talk about this too much and when we talk about linear equations, which is why we're talking about it now. So for each one of these situations, there's a pattern that goes with this where you can try to memorize it or you can just figure it out on the spot every time. Anyways, it works about the same way. So if I have x is less than 5 right now, the line that I'm trying to graph is the line x equals 5. And for me to graph that line, if you forget when you have x equals a number, whether it's supposed to be horizontal or vertical, just think about it as a line is made of infinite points. And in this case, I have infinite points where the x value is supposed to be 5. So I can graph one point with an x value of 5. So let's say like 5, 0. Doesn't really matter what you put down. It's important for you to remember that the x value is going to be 5. So then that's 1 point with an x value of 5, and then now I just need to pick any other y value for the point where the x value is 5. And once you make 2 points, that's enough for you to see that you are supposed to be graphing a linear line when you have x equals some value. And now, when you have to pick points where for true values in this inequality, you really just have to pick a point where the x value is smaller than the number they gave you. So in this case, x is supposed to be less than 5, so I can pick 3. And then once it doesn't matter what the y value is. And once you pick a point on one side of the inequality, that means all the points on that side of the inequality is your solution. And for y, we can do the same thing. I have y is greater than or equal to -2, so the line I'm trying to graph is y equals 2, which is multiple points where the y value was 2. So I can pick 0, 2, and 2, 2, just because I feel like it. Oh wait, -2. We're trying to graph y equals -2. So then 0, -2, and then 2, -2. Always good to check your work as you go through the problem. So then we have 1 point here and 1 point over here. And now, quickly enough, we notice that this is supposed to be a horizontal line. And y has to be greater than or equal to -2, so we can just pick point where the y value is bigger than that. So pick point where y is 0, and let's make x 0. Why not? Once you have 1 point on this side, that's your solution. The rest of the points on that side are the solution. And that's how you graph individual inequalities when you have only one variable. And now we have this knowledge with inequalities. We're going to use that to try a problem. All right, here we go. We have A. So guys, this is a big word problem, and this is one of those situations where we have where we don't have answer choices to go off of. So this is an open-ended question. So you're going to want to make sure that you show work so that you know how to solve through the problem, since this time I don't have 4 answer choices to pick one correct one out of. And we're going to talk about strategies for reading problems a little bit. Once again, the SATs, you're dealing with 58 math problems plus multiple English sections. So whenever it is possible for you to read less, you want to read less. So for a problem like this, you want to make sure that you're reading the question before you read the rest of the problem. That way it helps you get a bearing for what information is important and what information isn't. So the question is, what is the maximum number of hours for which Maria can rent the boat? So this is one of those linear equations where I need to describe cost. And all right, here we go. Maria plans to rent a boat. That's not really that important. The boat rent costs $60 per hour. That's important. And then she will also have to pay for a water safety course that costs $10. And Maria wants to spend no more than $280 for the rental and the course. And now, and then lastly, they are saying that the boat needs to be rented for a whole number of hours, and now we need to find the maximum numbers of hours for which Maria can rent the boat. So the best way to finish this problem is to be able to represent the situation with a good inequality. And if you know that the inequality is represented well, then you can solve it and be confident in your answer as you solve it. Okay, so this was the one sentence we didn't need. Let's try to write an inequality for the situation. Now, personally, I like to do it like this, but you don't always have to, especially if you understand the situation super well. But since I'm teaching this problem, I will show you how I usually do it. I don't always start the inequality with, and I don't always start the inequality and equation with all numbers, because it takes me a while to figure out what the numbers mean individually. What I like to do is to write the more complicated stuff in words. Like in this case, Maria wants to spend no more than $280 for the rental and the course. So I can say that the cost has to be no more than $280. And so I know that in this case, no more than is saying not greater than. And not greater than means less than or equal to. And that's the part I figured out by saying Maria wants to spend no more than $280. So now from here, I know that the cost has to be less than or equal to 280. Now I just need to represent the cost, which is a little bit easier now to break down because I have the other stuff figured out. Board rental costs $60 per hour, so that's 60x. And she says she has to pay for the water safety course that costs $10. And since that cost doesn't change, that's what you would call the constant. And here we are. And then from here, you just need to solve. And I know this is calculator. So that you can feel free to get your calculator out and do 270 divided by 60. But if you remember the fact that they're literally just asking for whole numbers, that means we can absolutely estimate. And I know 240 divided by 60 would give me 4. So 270 divided by 60 would give me 4 point something. You can stick like a 3 there or whatever. It doesn't really matter because you know that in this case you're looking for whole numbers, which means that if x has to be less than or equal to 4.3 something, I know that the largest number of hours that I can rent the boat for is 4 hours. And that is enough for me to be done with the problem. Okay. And now we move on to the concept of a different way to represent linear functions, this time through the eyes of a function. So far we have gotten very used to the concept of dealing with two linear equations with two variables, where I have something like y is equal to 3x plus 7. And this is pretty generic for something we've seen. But then there are other ways to represent linear relationships in the SATs, which mainly come in the form of functions. So another way you can see a function is something like this, which feels more intimidating because instead of dealing with y now they're saying something like fx, which reads weird and looks weird and feels more sophisticated. And this lesson is to show you that it's really, really not, as long as you have a good grasp of what this all means. So you can think of f of x as a big fancy way of saying y. And it reads as, and when you read this right here, you don't call this fx, you would call this f of x. And in layman terms, if we translate it into English, it is telling you the value when x is some number. And I'll show you a little bit of what that means in terms of, I'll show you what that means graphically, and then I'll show you what that means in terms of an example. So a function is essentially what counts as like a number producing factory. And when x is equal to some number, it gets put into the it gets put into the function as that number, and then the number that gets pumped out is essentially the number being pumped into the function. And then you get to make a statement saying that f of this number is equal to whatever this value ends up being. And if you think that's really, really similar to the concept of taking an equation And when x is equal to some number, then you put that number into the equation so that you can find y. And then you get the point for the x value and then the y value. Then you would be correct. They are essentially the same way of expressing things. Functions just do it differently because they give you an f and then a variable, and you read it differently. And now I'll show you an example, and then we'll move on with our lives with the problem. So if I give you the equation y is equal to 3x plus 7, and I put in a point like x is equal to 2, then I would find y by doing 3 times 2 plus 7, which is going to give me 9, and therefore I have the point 29, which reads when x is 2, y is 9. And as a function, I would write it like this, where they're always going to give you a formula, and then when they say f of 2, that is going to be me taking the function, and every time x shows up, I replace it with 2, and then I get this. And then I get to make the statement f of 2 is equal to 9, which says when x is 2, the function which funnily enough also gives me the point on the coordinate plane 2, 9. And understanding that the relationship between a function and a equation where one variable is isolated is really just in the way they look and nothing else is good, because that means all the stuff we learned last week about how equations work also applies to functions. Just as much as we've been doing all the stuff that we're doing for functions, we've learned our whole lives through using equations. So understanding those relationships is extremely important. And now, with that knowledge in mind, let's try our first problem for functions. Okay, I have this function right here where I have this table, n is 1, 2, 3, 4, and f of n is negative 2, 1, 4, 7. And now they're telling me which of the following defines f. So I will tell you that if you know how functions relate to in between variables, this question is going to take you exactly 2 seconds. But I'm teaching you this concept, so we're going to go a little bit slow to get you through it. Like I said before, you can always think of the function as y, and then the variable inside of the function as x. And now when we read through this, they're essentially giving us a set of coordinates where when the x value is 1, y is negative 2. And when the x value is 2, y is 1. When x value is 3, y is 4. They're straight up giving us coordinates. And having these coordinates means that I can write this into a linear equation. And if I can write it into a linear equation, I might as well call it a function. So now we really just need to treat this problem like a regular linear equation, and that's going to get us the function super, super quick. So first things first, I'm not going to try to discover the y-intercept. I'm going to try to discover the slope. Every time the x value seems to go up by 1, the y value is going up by 3. And having that concept means that I know I am dealing with a situation where y is equal to 3x plus b, and knowing that y is equal to 3x plus b tells me that I am going to be creating a function where f of n is going to be equal to 3n plus some other number. But for this question, I don't actually care because I know that f of n is equal to 3n minus 5 because that's the only one with a slope of 3. And understanding that relationship is why we know this is good to go. And one more thing I wanted to tell you about functions is that I know in the lesson I showed you and in this example, the function is defined as f. Not all functions need to be defined with the letter f. This reads as the formula f of x. But you can also get situations where you get g of x, which is just a different function, but now it's working off the formula of g. So you would read this as g of x and read this as f of x, but you can think of this as formula g, and you can think of this as formula f. And they all have the same functions. We're just using different letters to do the problem. And now we work on the relationship between variables, which I title this as directly related, but later on we'll really dive deep into the concept of what being directly related means. For right now, I want to use this to describe the relationships between variables in a linear function. Okay, so this should not be news to you anymore, but I still want to talk about it really quick. When you have y equals 3x plus 2, you want to make sure that you can have a good understanding of the description between the relationship of x and y, because a lot of the problems you do in the SATs deals with those topics. So in this case, if you always want to be able to answer when one variable goes up by one value, goes up by 1, how much does the y value go up by? And in this case, when the x value goes up by 1, I'm sure it doesn't surprise you at all to know that the y value goes up by 3. And with that same understanding, you should also have the knowledge that if x were to go down by 1, that means the y value would go down by 3. And even though we have 3x plus 2, the way the y value changes is entirely dependent on the slope. So this constant right here could be 200, and these relationships right here wouldn't change. And with that in mind, you also want to make sure you're very comfortable manipulating equations. So now, if the question wasn't how does y change when x goes up by 1 and goes down by 1, what if now we're trying to describe how much does the y value go up by, or when the y value goes up by 1 and the y value goes down by 1, how much does the x value change? And having this knowledge beforehand is always useful. And I will show you how to think about this. No doubt, I would expect that you guys are comfortable manipulating equations at this point. So if I were to minus 200 and then divide it by 3 and try to isolate x, x would be equal to y over 3 minus 200 over 3. And even though this is a grosser looking equation than the one I had before, you should understand that the constant does not describe how either variables change, but the slope does, and this slope is 1/3, meaning that when the x value goes up by 1, when the y value goes up by 1, that means the x value must be going up by 1/3, And likewise, when the y value goes down by 1, that means the x value goes down by 1/3. And understanding that relationship is going to be important because later on you'll get into weird situations where having that knowledge is super important. And I'll show you a really, really quick example before we move on. So let's say you have to deal with an equation where y is equal to negative 2/3 x plus 5. And just to make it a little more obnoxious, let's make it 5/6. Y equals negative 2/3 x plus 5. So now, if you had to answer the question like, when x goes up by 1, I wonder how my y value changes. Now it's a little bit tougher because when x goes up by 1 in this case, you're not really able to tell how the y value changes super, super easily. So then what you would do is you would try to isolate y on one side of the equation and then use the slope to determine your change in y as x changes by 1. And the way you would do this is multiply both sides of the equation by 6/5. And y would then in this case be negative 12 over 15 x plus 6. But the key thing here is to remember that the 6 is really not that important at all. What we get to focus on is that, okay, if y is equal to negative 12/15 x, that means when x goes up by 1, y goes down by 12 over 15. And then likewise, when x goes down by 1, y goes up by 12 over 15. And now, if I have the audacity to try to figure out how x changes when y goes up by 1 and then down by 1, I would simply multiply both sides by a negative 12 over 15, or, sorry, negative 15 over 12. And then over here, I'm not even going to bother figuring out what 6 times negative 15 over 12 is, because that's not going to help me describe the change between x and y. So now, when y goes up by 1, I would expect x to go down by negative 15. I mean, just go down by 15 over 12. And if the y value were to go down by 1, I would expect x to go up by 15 over 12. And this is a basic enough concept, but understanding the relationships and using it to your advantage is going to be a big help for you as you work through more and more linear problems where the concept is not particularly complicated, but the wording will be. And let's try one of those now. Okay, so here we have this equation describing the relationship between Celsius and Fahrenheit, and they want us to know, based on these equations, which of the following must be true. And in this case, C obviously means Celsius, F obviously means Fahrenheit. And I'm looking at this thing, and I'm going to tell you right now, even though we have a 5/9 times F minus 32 here, I'm really just focused on that 5/9 F. Every single one of these statements are about how one variable changes when the other variable changes by some certain amount. So when I try to distribute this, the 5/9 F is great. Notice that they're not letting me use a calculator, and I'm not really bothered by the fact that I don't know this off the top of my head, because understanding that if I'm trying to describe the relationship between these two variables, this number is pretty much irrelevant to me to begin with. Whatever constant it ends up being is useless. So now I can just try to describe everything based on this. And with that, we can think about how changes occur between these three things. So statement number one says a temperature increase of 1 degrees Fahrenheit leads to a temperature increase of 5/9 degrees Celsius. So if I were to take my Fahrenheit and increase by 1, it would make sense that the Celsius would increase by 5/9, because that's a number that's being multiplied by the slope. You get that part. So then that means 1 is definitively true. And now we get to knock out any option that doesn't include 1 in this option. So now we know that statement number 3 is definitely false. And now we have to try to see if statement number 2 is true. And if it is, then the answer is D. If it's not, then the answer is A. So a temperature increase of 1 degree Celsius is equivalent to a temperature increase of 1.8 degrees Fahrenheit. And this time, if you just try to increase Celsius by 1, it gets a little bit harder to think about what happens over here. So then what we're going to do is we're going to rework this equation. And that's another advantage of getting rid of that constant, because, this is way easier to solve. Multiply both sides of the equation by 9/5. So then F is equal to 9/5 C. So now I know if F goes up by 1, then if the Celsius goes up by 1. So now if the Celsius goes up by 1, then I know that the Fahrenheit goes up by 9/5, also known as decimal form 1.8. So then I get to really, really easily decide that number 2 is also true. So then answer is D. Problem like this doesn't seems like a lot when you first start, because you're trying to see how many out of the 3 statements are true, and there's usually a lot of words and a lot of sentences that can be confusing. But by understanding how to represent the work and know what to focus on and what not to focus on, you can get to the answer a lot quicker that way. So we just tried our simple problems of the day. Now we'll try something a little bit tougher for our last 2. Okay, this one's a long one. And start by figuring out what the question is, and then we'll work our way there. So the last sentence is, if more than 20% of all participants chose the first picture in the set, which of the following inequalities best describes the possible values of P? Okay, so then we have to recognize these 4 inequalities here, and then we can read the problem. One thing I would keep in mind right now is that our job is just to find the one correct answer out of these 4. And if all 4 of them have the same quality, that means it's not distinguishing for any of them. So for A, B, C, and D, they're telling us for every one of them that P is less than or equal to 150. So then for that matter, that P is less than or equal to 150 is not useful for me for any one of these 4 inequalities. So really all I'm caring about now is the formula. So let's try to read the problem and represent the work. So psychologists set up experiments to study the tendency of people to select the first item. We're presented with a series of items. So usually the first sentence with the intro is really, really not that important. And then we're going to read the rest of the problem. In the experiment, 300 people were presented with a set of 5 pictures. Each person was asked to choose the most appealing. Of the first 150 participants, 36 chose the first picture in the set. And then among the remaining 150 participants, P people chose the first picture in the set. And now they're telling us if more than 20% of all participants chose the first picture in the set, which of the following inequalities best describes the possible values of P? So this is one of those classic problems where it's a giant paragraph and they overload you with information from different parts of algebra, and you want to write an inequality that represents their work best. And there's a couple ways to go through this. I am going to show you one way I would do it methodically, and then I'll show you a slightly cheaper way to do it. So the way to do it methodically is we want to make sure we find the inequality that represents this situation best. So they're telling us that if more than 20% of all participants chose the first picture in the set, which of the following inequalities best describes the possible values of P. So P in this case represents the number of people that chose the first picture. And we're just trying to describe how many people are doing that. So the way you could think about it is we have 150 people from the first half that chose and 150 people from the second half. So of the first 150 participants, 36 of those people chose. And then among the remaining 150 participants, P people chose the first picture. So now, if more than 20% of all participants chose the first picture in the set, 20% of all participants is representative of 0.2 times a 300, because that's how many parts there are. And 20% really just means 0.2 as a decimal. So this right here describes the people that chose first. And this right here represents 20% of the participants. And they're saying if more than 20% of all participants chose the first picture in the set, then we can put this part together. This is all the people that chose the first picture, and say that it's going to be greater than 0.2 times 300. And that represents the inequality accurately. And between A, B, C, and D, that means D is going to be the answer. And that, I would say, is the super methodical way of figuring out how to do this problem here. And now I'm going to show you a different way to build it that I think is a little bit easier and uses our shortcuts and knowledge a little bit better. So this time I'm going to focus on the thing that's I'm going to focus on the statement they gave me at the end first and gradually build that up. So they said more than 20% of all participants chose the first picture in the set. So then what you can do is represent inequality that way using words. So more than 20% of all participants chose the first picture in the set just means that the number of participants that chose the first picture is greater than 20% of the total number of participants. And now we can just gradually piece, and now that you have this set up, everything else, you just have to piece together gradually. This part on the right is going to be 0.2 times 300, and then this part on the left is going to be the number of people that chose first, which you get to say is 36 from the beginning, and then the P people from the second set of 150, and then once again you'll notice that D is the correct answer. And this way to do it is a little bit easier to think through. And also, it can hurt. In this problem, you don't really need to do this, but it can't hurt to realize that in this question, A and B are both relatively silly answers. And if you have to choose between C and D, you should be adding by the 36 people instead of subtracting by the 36 people if you're trying to describe the total number of people that chose the first picture. So that's another way to really simplify the problem for yourself. And last one of the day, So if the graph of g passes through the point 0, -4, what is the value of g of 9? Okay, so if I'm trying to write what g of 9 is supposed to be, then I'm gonna have to be able to come up with a function for what the formula of g of x is, and then after that I can plug in 9. Fortunately, they give us a lot of hints. So the slope of the graph of the linear function g is 4 times the slope of the graph of f, and it passes through the point 0, -4. So I am trying to write g of x into a linear function, and I can figure out right now that the slope of x is going to be 1 over 2. So if my slope is supposed to be 4 times the slope of 1/2, that means I already know that g of x is going to be 2x plus b, and then the fact that they told us that it passes through the point 0, -4 means that they actually already gave me the y-intercept, where I know that the b value must then be -4. So now when they want the value of g of 9, I can just shove 9 into the function, and then I'll get to my solution super quickly. And I know we got through that problem relatively quickly, but that's because we have